Hello everyone, welcome back to my YouTube channel. This is part 2 of revision series of Mathematics 2 for class 12 students. We are going to discuss the previous year questions of differentiation. If you haven't watched the part 1, please watch it before. The link is in description. So first question is differentiate sine of x square plus x with respect to x. So here we have sine of x square plus x as a function. So in this, you can see that this is an example of composite function. Our standard form of function is sine x. So instead of x, we have here x square plus x. So there is a function inside a function. So here we will make use of chain rule. So let y is equal to sine of x square plus x. So if we differentiate with respect to x, dy by dx will be equal to derivative of sine of x square plus x. So sine x derivative of sine x is cos x. So we'll write cos of x square plus x. And now we are going to differentiate the function which is present inside, that is x square plus x. So derivative of x square plus x. So our final answer will be dy by dx is equal to cos of x square plus x into derivative of x square is 2x plus derivative of x is 1. So this is our final answer. So this was a PYQ of 2020 for 2 marks. Let us move to question number 2. Differentiate under root x square plus 5 with respect to x. Again, this is an example of composite function. So let y is equal to under root x square plus 5, differentiating with respect to x. So here we'll use the formula of derivative of under root of x. Root x derivative is 1 upon 2 root x. So this will be 1 upon 2 under root x square plus 5 into derivative of the function, that is x square plus 5. So derivative of x square plus 5 will be 2x. So final answer will be 2x upon 2 under root x square plus 5. 2 will get cancelled. So x upon under root x square plus 5. Question number 3. Differentiate cosec inverse of sec 5 raised to x with respect to x. So again you can see here, this is cosec and this is sec. Now here we can make use of inverse trigonometric formulas. So we can convert this sec phi raised to x into cosec. So let y is equal to cosec inverse of sec phi raised to x. Now we have converted this sec theta into cosec theta. So we can convert sec theta into cosec theta. The formula is sec theta is equal to cosec pi by 2 minus theta. So here theta is nothing but phi raised to x. So it will be cosec pi by 2 minus phi raised to x. Now sec phi raised to x we can write as cosec pi by 2 minus phi raised to x. Now using inverse trigonometric property, cosec inverse of cosec theta is nothing but theta. This cosec inverse and cosec will get cancelled. So y will be equal to pi by 2 minus phi raised to x. Now we'll differentiate it with respect to x. So dy by dx will be equal to pi by 2 is constant. So 0 minus derivative of phi raised to x, that is constant raised to variable. It is nothing but a raised to x log of a. So same way phi raised to x log of phi. So final answer will be minus phi raised to x log of 5. Question number 4. Differentiate cos inverse of 2x under root 1 minus x square with respect to x. Now in the previous video we have seen that whenever there is like this 2x under root 1 minus x square, this is our function, we substitute x is equal to sine theta. So if we substitute here x is equal to sine theta, we'll get theta is equal to sine inverse of x. So y will be equal to cos inverse of 2 sine theta into 1 minus sine square theta, that is cos theta. So 2 sine theta cos theta. This is nothing but sine 2 theta. So cos inverse of sine 2 theta. Now y will be equal to, now we'll be converting this sine into cos. So sine theta is equal to cos pi by 2 minus theta. So we'll write here cos pi by 2 minus, in this case theta is 2 theta. So 2 theta. Cos and cos inverse will get cancelled. Y is equal to pi by 2 minus 2 theta. Now we'll differentiate it with respect to x, but we don't have any term with x. So we will substitute the theta in the form of x. So theta is sine inverse of x. So y is equal to pi by 2 minus 2 into sine inverse of x. Now we'll differentiate it with respect to x. So we'll get dy by dx is equal to derivative of pi by 2 0 minus 2 is constant and derivative of sine inverse of x is 1 upon under root 1 minus x square. So final answer will be minus 2 upon under root of 1 minus x square. Question number 5. Differentiate tan inverse of 5x plus 1 upon 3 minus x minus 6x square with respect to x. In the previous session, we have discussed one formula. Tan inverse of a plus tan inverse of b is equal to tan inverse of a plus b upon 1 minus ab. So we have to make this expression in such a form that we can apply that formula. So let us see. Now here you can see in the numerator we have first one term and another term in addition. So to use the formula in denominator, we should have 1 minus a into b. So here we should get 1 minus something. So for that, we will add 1 and subtract 1. So here 5x plus 1 upon, we have add 1 and subtracted 1 and plus the term as it is. Now we will keep this 1 as it is here, 5x plus 1 upon 1 minus. We'll take minus as common. So this will be 6x squared plus x. 3 minus 1 is 2 and minus is common, that's why it will be minus 2. Now we have got 5x plus 1 upon 1 minus this quadratic equation. We will solve this quadratic equation and find its roots. So 5x plus 1 upon 1 minus 6x square plus 4x minus 3x minus 2. So roots are 2x minus 1 and 3x plus 2. Now, if we add this 2x minus 1 and 3x plus 2, we get the numerator 5x plus 1. So we can write the numerator as 2x minus 1 plus 3x plus 2 upon 1 minus 2x minus 1 3x plus 2. Now this is similar to tan inverse of x plus y upon 1 minus xy. So now here we can apply the formula tan inverse of x plus tan inverse of y. So this will be y is equal to tan inverse of 2x minus 1 plus tan inverse of 3x plus 2. Now we'll differentiate it with respect to x. So dy by dx is equal to tan inverse of x. Differentiation is 1 upon 1 plus x square. So it will be 1 upon 1 plus 2x minus 1 the whole square into derivative of this 2x minus 1 plus tan inverse of 3x plus 2. After differentiating, we get 1 upon 1 plus 3x plus 2 the whole square into derivative of 3x plus 2. So the final answer will be derivative of 2x minus 1 is 2 and derivative of 3x plus 2 is 3. So 2 upon 1 plus 2x minus 1 the whole square plus 3 upon 1 plus 3x plus 2 the whole square. Let us move to the next question. Question number 6. If x raised to 7 into y raised to 5 is equal to x plus y the whole raised to 12, prove that dy by dx is equal to y by x. So we have given one expression, x raised to 7 into y raised to 5 is equal to something. Now what we have to apply here? So you can see that we have discussed in the previous session, whenever there is a function in multiplication or function raised to power, then we solve it by logarithmic differentiation. So here we can apply log on both sides. So taking log on both sides, we will get log of x raised to 7 into y raised to 5 is equal to log of x plus y the whole raised to 12. Now we'll apply the properties of log. Log of a into b is nothing but log a plus log b, and log of a raised to b is b into log a. So here log of a into b will be log of x raised to 7 plus log of y raised to 5 is equal to 12 log x plus y. Again here we'll apply the property log of a raised to b 7 log x 5 log y is equal to 12 into log of x plus y. Now this we have simplified. Now we'll differentiate it with respect to x as we have to find dy by dx. Okay, so after differentiating with respect to x, we'll get 7 is constant, log x derivative is 1 upon x plus 5 log of y. Now we are differentiating with respect to x. So this is now a composite function. So 5 into 1 upon y, derivative of log y is 1 upon y into dy by dx because we are applying a chain rule. That is equal to 12 is constant, log of x plus y, derivative will be 1 upon x plus y. Again, this is a composite function, so we take derivative of x plus y. So you will get 7 upon x plus 5 upon y dy by dx is equal to 12 upon x plus y derivative of x plus y with respect to x, that is 1 plus dy by dx. Now we'll open this bracket. 7 upon x is equal to 5 upon y dy by dx is equal to 12 upon x plus y plus 12 upon x plus y dy by dx. Now there are two terms of dy by dx, we'll take it common. So 5 minus y minus 12 upon x plus y dy by dx is equal to 12 upon x plus y minus 7 upon x. Now we'll do cross multiplication. So this will be 5x plus 5y minus 12y upon xy plus y square into dy by dx is equal to 12x minus 7x minus 7y upon x square plus xy. So dy by dx will be equal to, we'll solve this 5x, 5y minus 12y is minus 7y, 12x minus 7x is 5x. 5x minus 7y and 5x minus 7y will get cancelled. So dy by dx is equal to x square plus y square upon y square plus xy upon x square plus xy. So here we'll take y common. So it will be y plus x. Here we will take x common, x plus y. Again, y plus x and x plus y will get cancelled. The final answer will be y by x, which we have to prove. So hence proved. Let us move to the next question. If e raised to x plus e raised to y is equal to e raised to x plus y, then prove that dy by dx is equal to minus e raised to y minus x y. Now here we have both variables x and y, and we cannot separate these both variables. So this is nothing but a implicit function. So here we'll directly differentiate with respect to x and solve for dy by dx. So solution, differentiating with respect to x. So e raised to x will get e raised to x plus derivative of e raised to y. Now this is a composite function. So e raised to y into dy by dx is equal to, again, e raised to x plus y into derivative of x plus y. So this will be equal to e raised to x plus e raised to y dy by dx is equal to e raised to x plus y into derivative of x plus y is 1 plus dy by dx. Now we'll open the brackets. So this will be e raised to x plus y plus e raised to x plus y dy by dx. I will take this dy by dx common. So you will get e raised to y minus e raised to x plus y into dy by dx is equal to e raised to x plus y minus e raised to x. Now we have to find dy by dx. So dy by dx will be equal to e raised to x plus y minus e raised to x upon minus e raised to x plus y plus e raised to y. Now we already know what is e raised to x plus y. So in the question it is given e raised to x plus y is e raised to x plus e raised to y. So we'll substitute in the place of e raised to x plus y, e raised to x plus e raised to y. So we'll get here e raised to x plus e raised to y minus e raised to x upon, again here minus of e raised to x plus e raised to y. So after opening the brackets, we'll get minus e raised to x minus e raised to y plus e raised to y. Now this plus e raised to x minus e raised to gets cancelled. Here minus e raised to y plus e raised to y get cancelled. So answer becomes minus e raised to y upon e raised to x. And using the indices property, we can write minus e raised to y minus x. This is what we have to prove. Let us move to question number 8. This is a PYQ of 2023. So if y is a function of x and log of x plus y is equal to 2xy, find the value of y dash of 0. So let us first write what is a given part. So they have given y is a function of x and they have given log of x plus y is equal to 2xy. We have to find the dy by dx when x is equal to 0. So what is the meaning of y dash of 0? Y dash of 0 means you have to find the first order derivative of function y when x is equal to 0. So first we'll differentiate with respect to x. So we'll get here 1 upon x plus y, log of x plus y is 1 upon x plus y into derivative of x plus y, that is 1 plus dy by dx, is equal to 2 is constant, and here we will apply UV rule. X into derivative of y is dy by dx plus y into derivative of x is 1. So we'll get this. Now in the question we have to find y dash of 0. Y dash of 0 means when x is equal to 0. So we'll Substitute the value of x in our original equation. So here log of 0 plus y is equal to 2 into 0 plus y. So this will be log y is equal to 0, that is y is equal to e raised to 0, that is y is equal to 1. So that means when x is 0, the value of y is 1. So we'll substitute the value of y here. We'll get put x is equal to 0 and put y is equal to 1. So 1 upon 1 plus 1, that is 1, into 1 plus dy by dx is equal to 2 into x is 0 plus y is 1. So here you get dy by dx is equal to 2 minus 1, that is equal to 1. Let us move to the next question. Again, this is a PYQ of 2023, which is asked for 3 marks. So we have given y is equal to root of tan x plus root of tan x plus root of tan x up to infinity. And we have to show that dy by dx is equal to sec square x upon 2y minus 1. And also find y dash of 0. So in this question, what we do is, we keep the first term as it is, that is root tan x plus. Instead of this, we substitute it with original equation, that is y, because they have given us y is nothing but root tan x plus root tan x up to infinity. This is also root tan x plus root tan x up to infinity. So here our modified equation becomes y is equal to under root tan x plus y. Squaring on both sides, y square is equal to tan x plus y. Now we'll differentiate with respect to x. So this will be 2y into dy by dx, because we are differentiating with respect to x and here it is y. So we'll apply the chain rule. 2y into dy by dx is equal to derivative of tan x is sec square x plus derivative of y is dy by dx. So we'll take the dy by dx terms common. So 2y minus 1 into dy by dx is equal to sec square x. So that dy by dx is equal to sec square x upon 2y minus 1. So this is the first part of the question which we have proved. Now let us solve the next part of the question. So here we have to find derivative when x is equal to 0. So when we substitute value of x is equal to 0, first we have to find the value of y. So here, if we substitute value of x0, so it will be tan 0 plus under root tan 0 plus under root tan 0 up to infinity. And tan 0 is nothing but 0. So 0 plus 0 up to infinity, it will be 0. So y will be also equal to 0. Now we'll substitute here dy by dx is equal to sec square 0 upon 2 into 0 minus 1. So sec square 0 is nothing but 1. So it will be 1 upon minus 1. So our dy by dx will be equal to minus 1. So this will be your answer. Okay. Let us move to the next question. Question number 10. If x is equal to sine t and y is equal to cos t, find dy by dx. Now this is nothing but parametric function. X is a function of t and y is also function of t. So x is equal to sine t, y is equal to cos t. To solve for dy by dx, first we'll solve differentiate x with respect to t, differentiate y with respect to t, and then divide it. So dx by dt will give us sine t derivative is cos t and dy by dt will give us minus sine t. So dy by dx is equal to dy by dt upon dx by dt, that is equal to minus sine t upon cos t, which is equal to minus tan t. So this is also PYQ of 2022, which asks for 2 marks. Let us move to the next question. Question number 11. If x is equal to a cos cube t and y is equal to a sin cube t, prove that dy by dx is equal to minus y by x the whole raised to 1 by 3. So same, this is also a parametric function. X is a function of t, y is a function of t, and we have to solve for dy by dx. So first we will find dx by dt. So a is constant. Derivative of cos cube t is nothing but 3 cos square t into derivative of cos t, that is minus sin t. So after rearranging this, we get minus 3a sin t cos square t. Same way dy by dt is a is constant, 3 sin square t into derivative of sin t is cos t. After rearranging, we get 3a cos t sin square t. Now we have to find dy by dx. Dy by dx is nothing but dy by dt upon dx by dt. So we'll divide both this. So 3a gets cancelled. Here sin t and 1 sin t gets cancelled. Cos t and 1 cos t gets cancelled. So you get minus sin t upon cos t. Now if you see here, we want the answer in terms of y and x and not in terms of t. So here from this equation, x is equal to a cos cube t and y is equal to a sin cube t, we'll solve for cos t and sin t. We'll take cube root from both the sides, so it will be y raised to 1 by 3 is equal to a raised to 1 by 3 sin raised to 3 by 3, that is sin t. Therefore, sin t will be equal to y upon a the whole raised to 1 by 3. And similarly, cos t will be x by a the whole raised to 1 by 3. Now we'll substitute this here. So dy by dx is equal to minus y by a whole raised to 1 by 3, x by the whole raised to 1 by 3. A raised to 1 by 3, a raised to 1 by 3 will get cancelled. Final answer will be minus y by x the whole raised to 1 by 3. Next question is, if if y is equal to x log x, find d2y by dx2. Now we have moved to higher order derivatives. So first we will solve for dy by dx, then again we'll differentiate, then we'll get a second order derivative. So dy by dx, here you will apply UV rule. U into derivative of v is, that is log x, is 1 upon x plus log x into derivative of x is 1. So dy by dx is equal to 1 plus log x. Now this is dy by dx. Now we want to find d2y by dx2, second order derivative. Again we have to differentiate this. So again differentiating with respect to x, this will be derivative of dy by dx is equal to derivative of 1 plus log x. Derivative of dy by dx will be d2y by dx2 is equal to derivative of 1 plus log x, derivative of 1 0 plus derivative of log x 1 upon it. So this is your answer. Question number 13. Find d2y by dx2 if x is equal to a cos cube theta, y is equal to b sin cube theta. Now this is an example of parametric function and we have to find second order derivative of this. X is equal to a cos cube theta, y is equal to b sin cube theta. So first we'll find dx by d theta. So here we'll get a is constant, 3 cos square theta minus sin theta. After rearranging, minus 3a cos square theta sin theta. Similarly, dy by d theta will be 3b sin square theta cos theta. Now we have to find dy by dx. So dy by dx will be dy by d theta upon dx by d theta. The same steps which we have done in previous question. So final answer will be b sin theta minus b sin theta upon a cos theta. Sin theta upon cos theta will be tan theta minus ba upon tan theta. Now we have to find d2y by dx2. Means you have to differentiate this equation again. So again differentiating this, derivative of dy by dx is equal to derivative of minus b upon a tan theta. Now here we are differentiating with respect to x and here the variable is theta. So this will be d2y by dx2 is equal to minus b upon a is constant. Derivative of tan theta is sec square theta. But we have to differentiate with respect to x. Therefore, we have to take the derivative of theta as well. Chain rule. So into d theta by dx. This will be equal to minus b upon a sec square theta into d theta by dx. Now we already know what is dx by d theta. So we'll just take the inverse 1 upon dx by d theta. And we'll substitute the value of dx by d theta from this. So it will be minus b upon a sec square theta upon 3 minus 3a cos square theta sin theta. Now from here, 1 upon cos square theta is nothing but sec square theta. So sec square theta into sec square theta will be sec raised to 4 theta. Minus minus will get cancelled. 3a square sin theta. This will be our answer, d2y by dx2. Now we have to find at theta is equal to pi by 4, what will the value of d2y by dx2. So we'll substitute theta is equal to pi by 4. b sec raised to 4 pi by 4, 3a square sin pi by 4. Sec pi by 4 is root 2. So b root 2 the whole raised to 4. 3a square sin pi by 4 is 1 upon root 2. So root 2 the whole raised to 4 means root 2 multiplied by root 2 into root 2 into root 2. So that will be you 4. So 4 and this root 2 will come in numerator. So 4 root 2b upon 3a square. This will be your final answer. So this is a PYQ of 2022 asked for 4 marks. Okay. Next question, question number 14. If y is equal to cos of m cos inverse x, then we have to prove this. So what the things are there in this? So we have to find dy by dx Also, you can see a d2y by dx2. That means we have to find the second order derivative also. So let us first simplify the question. So y is equal to cos of m cos inverse of x. So if we differentiate it with respect to x, dy by dx is equal to cos x derivative is minus sin x. Now this is a composite function. So again we'll differentiate m cos inverse of x. So dy by dx will be equal to minus sin m cos inverse x into derivative of m cos inverse x. M is constant. Derivative of cos inverse x is 1 upon under root 1 minus x squared. For simplification, now we have to take the double derivative also. So we will shift this under root 1 minus x squared in LHS. So you'll get under root 1 minus x squared dy by dx is equal to minus m sine of m cos inverse x. So squaring on both sides, we get 1 minus x squared dy by dx the whole square is equal to m square sine square m cos inverse x. Now we will differentiate again with respect to x. So if we differentiate again with respect to x, we'll apply here u into v rule. So u into derivative of v. So this is dy by dx the whole square. Again, this is a composite function. We'll treat this dy by dx as a x. So x square derivative is 2x. So 2 into dy by dx into derivative of dy by dx plus now v dy by dx the whole square into derivative of u minus 2x. So this is our LHS. Now in RHS, m square is constant. Sine square m cos inverse x. I have to derivate this. So this will treat as x square. So it will be 2 into x. X is sine into m cos inverse x into derivative of sine into m cos inverse x. So after solving, we'll get 2 into 1 minus x square dy by dx into derivative of dy by dx is d2y by dx2 minus 2x into dy by dx the whole square is equal to m square 2 sine m cos inverse x. Derivative of sine m cos inverse x. First, we'll find derivative of sine x, that is cos m cos inverse x. Again, into derivative of m cos inverse x, that is m upon under root 1 plus x, 1 minus x square. Okay. Now, LHS will be as it is equal to sine m cos inverse x. This term into m upon under root 1 minus x square. This is nothing but dy by dx from equation number 2. And negative sign we have to keep. So minus dy by dx. And cos into m cos inverse of x is nothing but y from equation number 1. So instead of writing these terms, we'll substitute minus dy by dx into y from 1 and 2. Now we'll simplify. Now from the what we have to prove is here we want 1 minus x square and d2y by dx2. So we'll divide it by dy by dx into 2. So divide whole equation both sides by 2 dy by dx. So you'll get here 1 minus x square d2y by dx2. From here 2 will get cancelled and one term of dy by dx will get cancelled. So minus x dy by dx. From here 2 will get cancelled and dy by dx will get cancelled. Minus m square y. This is what we have to prove. I hope you understood how we have solved this sum. This also asked in 2023 for 4 months. Let us move to the next question. Question number 15. If y is equal to e raised to m tan inverse of x, show that 1 plus x square d2y by dx2 plus 2x minus m dy by dx is equal to 0. Again, PYQ of 2022 for 3 marks. So again, here we have to first find the dy by dx, arrange the terms, and then find d2y by dx2. Again, arrange the terms. We'll get the answer. So y is equal to e raised to m tan inverse of x. Differentiating with respect to x, we'll get dy by dx is equal to e raised to x is nothing but e raised to x into derivative of m tan inverse x. That is m into 1 upon 1 plus x square. So dy by dx will be m e raised to m tan inverse of x upon 1 plus x square. Now we'll take this 1 plus x square in the LHS. So we'll get 1 plus x square into dy by dx is equal to m e raised to m tan inverse of x. Now we can simplify this. E raised to m tan inverse of x is nothing but y. So instead of this, we will simply put y. from equation number 1. Now I will differentiate it with respect to x again. So you'll get u into v. So u into derivative of v, dy by dx derivative is d2y by dx2 plus dy by dx as it is derivative of 1 plus x squared 2x is equal to m is constant and derivative of y is with respect to x is dy by dx. 1 plus x squared into d2y by dx2 plus dy by dx into 2x minus m will take common, dy by dx is common, so 2x minus m is equal to 0. This is what we have to prove. Question number 16. If log of x cube minus y cube upon x cube plus y cube to the base 10 is equal to 2, show that dy by dx is equal to minus 99x square upon 101 y square. So in this type of question, first we convert log into exponential form. So how to convert log into exponential form? So we have one property that is log of b to the base a if it is equal to m. So b will be equal to a raised to n, a raised to m. So this property we will apply here. So here converting to logarithmic exponential form, converting to exponential form, not logarithmic form, converting to exponential form, x cube minus y cube upon x cube plus y cube is equal to, we'll apply this a raised to m. So in this case, our a is 10 and m is 2, so 10 square. This will be equal to x cube minus y cube is equal to, this will be 100, 100 into x cube plus y cube, 100 x cube plus 100 y cube. If we simplify it, we'll get minus 99 x cube minus 101 y cube is equal to 0. We'll keep y term in LHS, x term in RHS, since we have to find dy by dx. We'll differentiate it with respect to x. So minus 101 is constant, and derivative of y cube with respect to x is 3y square into dy by dx is equal to 99 3x square. This 3 and 3 will get cancelled. So get dy by dx is equal to 99 x square upon minus 101 y square, which we have to prove. So this is a simple question. Only the thing is we have to convert this log into exponential form. And for that, you have to make use of this property. Let us move to the next question. Differentiate 3 raised to x with respect to log x to the base 3. Now this type of question is differentiating one function with respect to another function. So here we assume the first function as u. So let u is equal to 3 raised to x. Second function be v. V is equal to log x to the base 3. And we have to find du by dv. Differentiate 3 raised to x with respect to log x. So du by dv. Differentiate u with respect to v. Now u is a function of x. V is a function of x. So this is a parametric function. First we'll find du by dx and dv by dx. So du by dx is equal to a raised to x, 3 raised to x log 3. And dv by dx is log x, derivative of log x, but here the base is not e, base is some constant. So it is 1 upon x log of constant. So here it is 3, 1 upon x log 3. Now du by dv will be du by dx upon dv by dx. That is 3 raised to x log 3 upon 1 upon x log 3. So this will go in numerator x 3 raised to x log 3 the whole square. So this is your answer. So I hope you understood how we solve these questions. So in these 17 questions, we have covered all the types of questions: composite functions, parametric function, implicit function, logarithmic differentiation, differentiation of one function with respect to another function, then higher order derivatives. In that also parametric functions are there, and we have to find higher order derivatives like this. So these some questions are for practice. So the 17 questions which we have discussed, and these 7 questions, there are total 24 questions, and all these 7 questions are similar to the questions which we have discussed now. Okay, try to solve these questions. I hope you understood this session, and here we have completed the chapter number 1 revision. So do like, share and subscribe our channel for more videos. Thank you.